Yesterday, you had a word problem that generated two equations. It had the 6x plus 2y equals 24 from strawberries and blueberries and how I spent $24. And it also had y equals 3x because I bought 3 times as many of one as I did the other. Now, I had you make a table and you had to fill it in and you had to look for the point where it worked. You could graph it. And if you graphed it, you would have seen two lines, and you'd have to find the point where they intersect, and that would give you the answer. But today we're going to look at an easier way to do this. And this way is called substitution. When we think about substituting one thing for another, it means to replace. And that's the whole secret to this. If I look in the left equation, I have 6x plus 2y equals 24. But the right equation tells me y equals 3x. Y and 3x are the same thing. They can be substituted for each other, and it doesn't change anything because they're equal. That is the trick. Since I have a y in this left-hand equation, I can take 3x and substitute it in. That gives me a whole new equation. You'll notice most of it stays exactly the same. Still starts with 6x. It still has a 2, but instead of the y, I now have this 3x filling in its spot. And the whole thing still equals 24. I've just made that switch, that substitution of replacing two things that this equation told me were the same thing. Now I have to simplify. To do that, it's not too bad. The 6x in the beginning, nothing's happening to it, so it's going to stay the same. But this part right here is being multiplied. So 2 times 3x gives me 6x equals 24. 6x plus 6x, I can combine that and get 12x equals 24. Divide by 12 for both sides, and I have an answer of x equals 2. On my table, 2 was the spot where everything worked. 2 is the x coordinate on the graph where they intersect, but I don't have the y coordinate. That is simple. Take the 2, plug it into either one of the two equations. I usually pick the one that looks easiest. In this case, it tells me y equals 3x. Since x is 2, it's 3 times 2. So y is 6. These two lines, when they cross, when they intersect, I get 2, 6. Easy enough. Let's try a couple other problems, see if we can do the same method. You'll notice here I have two equations. Once again, one of them is in standard form. That's where I have x and y on one side being combined to equal some total. The other one on the other side is slope intercept. And I'm going to have to combine these two. I'm going to do it the same way. I'm going to say, look at this equation. Y and 2x plus 1 are equal. So I can substitute them back and forth. So when I have this y in this left-hand equation, this 2x plus 1 can get put in its place. Just pause the video for a second and see if you can write what the new equation is going to look like after that substitution. All right, hopefully you had a chance to write it, and if you did it correctly, it should look like this. All I did was copy the entire first equation and keep everything except the y exactly the same. But where the y was, I just filled in a 2x plus 1 in parentheses. Now, take a minute, pause the video, and see if you can simplify this down. When you're done, unpause the video, and I'll show you how I did it. So here's my work. Nothing's really happening to the 2x. But this is a distribution. It's going to be 4 times 2x to get me 8x. and it's going to be 4 times 1 to get me plus 4. And it all still equals 24. I'm going to combine like terms. These two things are going to go together. I'll have 10x plus 4 equals 24, minus 4 from both sides. 10x is equal to 20, so x is 2. I have half of the coordinate where they cross, where they intersect. I still need the y number, though. And the way I get that is I take it and I plug it into one of the equations. If x is 2, and this tells me 2x plus 1, I do 2 times 2 plus 1, and I get an answer of 5. 2 comma 5. I know it works for this right equation. I could plug it into the other one. 2 times 2 plus 4 times 5 equals 24. It works for that one. Since it works for both, that's the answer. 2, 5 is the point where they cross on a graph. One of them does something like this. The other does something like that. And there we go. This is the last of the normal problems we're doing today. Same deal. I want you to take this, plug it in for y, see what you get. Pause the video while you do that. When you unpause, I'll show you what I got. And when I made the substitution, I got something that looked like this. You'll notice that once again, most of the problem stays the same. I have a 2x minus 3 in each equation. Instead of y, in parentheses, I wrote this 2x minus 1 because I knew that that was the same thing as y. And over on the right-hand side, it still is going to be equals negative 5. It's just that one tiny piece being replaced or substituted. Now it's just simplifying. Try that, but be very careful and remember that this is a negative 3 being distributed. Pause the video, see what you can get. And here's mine. So when I did it, 2x, nothing happens, minus 3. Negative 3 times 2x is negative 6x. Negative 3 times negative 1, that's going to be plus 3 equals negative 5. Those look like they can combine. 2x minus 6x is negative 4x plus 3 equals negative 5. Minus 3 from both sides. Negative 4x equals negative 8. Divide by negative 4, and I get x equals 2. Now, that tells me where they intersect has an x-coordinate of 2. Just like before, to figure out what the y-coordinate's going to be, I'm going to take this, plug it into one of my equations. 2 times x minus 1, so it becomes 2 times 2 minus 1, which gives me 3. If I wanted to double check it, I'd plug in both of them into the other equation. 2 times 2, that's 4, minus 3 times 3, minus 9, does give me negative 5. It works for both. That means 2 comma 3 is that point of intersection on the graph. It's where both of them are going to cross. So I have 2 lines. That's what happens. The last one I want to make you look at today is kind of a special case, and it's something you're going to see every so often. First up, you'll notice I still have one in slope-intercept form, and I have one in standard form. I just wrote them in the opposite sides because I don't want you to get used to always seeing the problem the same way. That means that this y right there is going to be replaced with 2x plus 5. So let's do that real quick. You can pause the video, not pause the video, whatever works for you. When I did it, I got this. And I'm thinking everything's going to plan. So I just plow on ahead, do what I can. So that negative 4x is going to stay the same. Now it looks like I just have to do some distributing. 2 times 2 is plus 4x. And keep on going. 2 times 5 is plus 10. And now I'm starting to get suspicious. because when these things combine, negative 4x and 4x becomes 0. It goes away. And I'm left with 10 equals 10. We've seen this before. We saw it a few weeks ago. And we should remember what that means. Whenever it simplifies down and there's no variables, and I just get two numbers, and it works out to be something that is true, what's that tell us? It tells us that this has infinite solutions. On a graph where I'm trying to find the point where they cross, what actually happened is I had one line and the other line is exactly the same. So there isn't a single point of intersection. They're intersecting every single place along this line. Now, if I'd done this problem and at the end of it I got something like 4 equals 10, you should also remember what that means. That's a problem with no solutions. So, just like before, we can get one solution, we can get infinite, or we can get no solution depending on what we get. Try a couple problems today. Let's see how we do.